Alright guys, so we are going to start something other than lines today. We are going to start another type of function. So go ahead and open your notebook, page 44, and label it 13.1, graphing piecewise functions. Now we're doing a lot more than graphing piecewise functions, and I'll explain what a piecewise function is in just a second, but we're doing more than graphing them. We're going to graph them, we're going to create them, we're going to identify what's going on with them, a lot of things that go with that. Now, since we have, or talking about piecewise functions, you're going to need to pull out a calculator. So pull out a calculator or get one on your Chromebook. But go ahead and pull that out. Okay, you have attached in this a copy of the notes for today. Here they are, look like this. Remember, if you don't have a printer, that's fine. You're just going to be writing those on page 44. We're going to talk about piecewise functions. While we're doing that, I'm going to be pulling up my calculator. So I'm going to minimize this for a minute and pull up my calculator. Should have already had it pulled up, but of course not. There it is. So a piecewise function is just a function that is literally in pieces. So we'll have different pieces of a function. We base that on the domain. Need to make sure this is always in the front. Always in the front. And I want it to be in the beginning. Okay, here we go. So, alright, so a piecewise function is just a function, like I said, that's in pieces. Before we talk about that, though, we're going to do a quick review of how to find a function value when we are given a function. So we're given this function, f of x equals x squared minus 5. And we're going to plug each of these values in for x. Okay, so let's start with f of 1. So if I plug negative 1 into the function, I will have negative 1 squared minus 5. So I'm plugging it in for that value there. And I'm going to use the calculator for this. So parentheses, negative 1, close parentheses, squared. That's not squared. I'm going to delete that. Squared, okay, minus 5. I'm going to get my value. So that value is negative 4. Okay, there's the first one. F of negative 1 equals negative 4. Let's do the next piece. We're going to plug in for 0. We're doing this as a quick review because we're going to do it with piecewise functions next. F of 0 equals 0 squared minus 5. Now, it's very possible you know the answer to this without actually typing it in. That's fine. You don't have to type it in if you can do it in your head without it. Okay, that gives us negative 5. Okay, and let's do f of 3. So for instance, what I mean by doing it in your head, 3 squared is 9, and 9 minus 5 is 4, so this one is actually 4. So that's what I mean by doing it in your head. It's possible to do it in your head. So these are our 4 values here. Not 4, our 3 values here that it told us to find. We're going to do that now with a piecewise function. So a piecewise function is just a mixture of functions. We've had exponential, we've had linear, we've had quadratic, square root. It's just taking all of those, putting them into a function. I'll show you a graph of one, where we just have certain pieces. So see, we have these pieces. It looks a little strange because I've got more than one function going on here. They're just for different parts of the domain. So we're going to start talking about the different parts of the domain and what I mean by that. You're going to need highlighters out to talk about the different parts of the domain. And we're going to talk specifically about the domain. So in this piecewise function, it says we're supposed to evaluate. Before we worry about evaluating, we need to talk about the domain itself. In a piecewise function, you have certain rules. For instance, the function is equal to negative x if the x value is less than 2. So we're going to highlight that in green. You'll see that in a minute. Okay. We will have 2x plus 3 if the x value is between 2 and 4. And then we will have x squared if x is greater than or equal to 4. Okay? So let's talk about this. Let's go over here. The first one says find f of negative 2. Well, that means x is going to be negative 2. So I have to look at the domain. Where would the domain of negative 2 be? Well, is negative 2 less than 2? Yes. Okay, that means we're going to be using this one. So we're going to use the green function here. That means we will be using, for f of 2, f of negative 2, we will be using f of x equals negative x. Okay, so we're going to plug in a negative 2. F of negative 2 equals negative parentheses negative 2. And a double negative is just positive 2. Of course, I could plug it in the calculator if I really needed to, because it will do that for you, but you shouldn't need to for negative negative. There's the first value. All right, let's look at the next one. F of negative 0.4. Well, where is negative 0.4? It's still less than negative 2. Sorry, less than positive 2, so we're still going to use that green function. So we're still using f of x equals negative x. So f of negative 0.4 equals negative 0.4, which, as we discussed, is just 0.4. Okay, let's keep going. So this one was also in green. All right, the next piece, 3.7. Is 3.7 less than 2? No. Okay, is 3.7 between 2 and 4? Yes, it is. That means we will be using the orange function. So for f of 3.7, we will be using f of x equals 2x plus 3. I gotta make these boxes bigger. I'm not doing very good about that. So f of 3.7 equals 2 times 3.7 plus 3. And use the calculator for that. 2 parentheses 3.7 close plus 3. I got 10.4. So that means it is 10.4. Okay, last one, f of 5. Is 5 less than 2? No. Is 5 between 2 and 4? Also no. Is 5 greater than or equal to 4? Yes. So we will be using the pink function. So f of 5, we will use f of x equals x squared. So f of 5 equals 5 squared. 5 squared is 25. So there are our 4 evaluations for the piecewise function. Let's do the next one. We're going to do the same thing. We're going to highlight our domain, and then we will match where each piece goes. So for the first one, we have x is less than or equal to negative 2. The next set, we have x is between negative 2 and 0. And the last set, when x is greater than 0. So let's look. We start with f of negative 3. We need to determine where that's located. Negative 3 is less than negative 2, so that means we will be using that first one there. So f of negative 3 means we are going to use f of x equals 2 divided by x. So we will plug in a negative 3. F of negative 3 equals 2 over negative 3. By the way, when we divide 2 by negative 3, we get a decimal, and we don't want a decimal, we want this fraction. Leave it as 2/3. All right, the next one, f of negative 1. I should have highlighted this one. F of negative 1. Negative 1 is not less than negative 2. Okay. Negative 1, is it between negative 2 and 0? Yes. So we're going to use the orange function, the middle function. F of negative 1. So f of x equals x. Plug in a negative 1. And this one, it's just that x and x is the same. We're finished. We don't have to do any calculations. Okay. Last, f of 1. 1 is not between negative 2 and 0, but 1 is greater than 0. It's a pink. Okay. F of 1. So we're using f of x equals 1. Well, this one's really nice because I don't plug anything in. There's no x. I just say f of 1 equals 1. So there's my answer. All right, you need to pause the video and try the one that says your turn. I'm going to go ahead and be working it, but you should pause it. Negative 4 is less than negative 3. Negative 2.9 is between negative 3 and 0. .9 is greater than 0. Okay, so f of negative 4 means we use f of x equals negative 5. That means we just plug in a negative 5 for f of x, but not a negative 5, very sorry, a negative 4. But remember, there was no x, so there's nothing we could do. That means when we graph it, it's just going to be a horizontal line, by the way. All right, f of negative 2.9. F of x equals x plus 2. So f of 2, negative 2.9, equals negative 2.9 plus 2. You can either type it in your calculator or do it in your head. F of negative 2.9 equals negative 0.9. And last, f of 1.9. Which we use f of x equals x squared plus 7. And I will have to use a calculator for that. F of 1.9 equals 1.9 squared plus 7. Let's see what that is. $10.61. Okay, that is how you evaluate a piecewise function. Now we're going to talk about graphing. Not exactly graphing. We're going to match some equations to graphs so that we can learn how to graph. So go ahead and open this up. Okay. We are going to look at our functions. We are going to match them. Then later we're going to write our own. So first of all, though, the first thing we always need to notice is the actual domain. So in the first one right here, our domain is -3, so when x is less than -3, and when x is greater than or equal to -3. There are quite a few things to talk about there. This means I'm going to have an open circle around -3. I'm going to have a closed circle around -3. A number by itself is a horizontal line. This says the y-intercept is at -3, and the slope is 1. Let's see if we can go find that. Here is how we're going to find that. We need to see where something changes around x is 3. So let's look. They change right here when x is 1. So see, it changes. We have this function, and then it changes to this one. So our number 1 does not match with this one. It changes at 1, but ours changes at -3. Okay, B changes in 2 places. We have 0, and then we have 2. So it actually has a gap, kind of. So here and here. So the answer is not B. We need it to change at 3. Okay, letter C. It changes directions at 0. So we start out here, and then we change to 0. So C is not the answer either. D changes in 3 places. 1, 2, not 3 places, but it's got 3 pieces of the domain, which means we'll need another color. So we have the first set of the domain, the second set of the domain, and the third set of the domain. All right, so it still can't be D since we are looking for something that changes at -3. Okay, let's look at E. E changes, at -3. We'll have to see if it matches. So we have from here to here, as well as from here to here. Okay, let's go up and see what it says. It says we should have a horizontal line to begin with. Does E have a horizontal line? Yes, not only does it have a horizontal line, it has an open circle. The horizontal line also matches with 5 up here. Okay, then, do we have a closed circle? Zoom out so you can see. We do have a closed circle. Does it touch the y-intercept at -3? Yes. Is the slope 1 of 1 over 1? Yes. The answer to number 1 is E. Number 2. We are looking for something that changes at 1. Do we have something that changes at 1? A, and F. So we'll have to decide, is it A or is it F? So we have this and this. So let's look at F. F also changes at 1. We will have to look at our slopes. We'll have to look at our open and closed circles to determine which one number 2 is. So number 2. Number 2 starts with a closed circle and then has an open circle. So let's look at A. It's closed, then open, and then F. Closed, then open. So that doesn't help us. All right, then a number by itself is a horizontal line. Let's see if that helps us. Horizontal line, not a horizontal line. The answer has to be A then. Okay, let's keep going. Number 3. I'm going to get rid of the calculator for right now. We don't need that. All right, number 3. Let's see where our domain's changing. It changes at 0 with an open circle. and at 2 with a closed circle. Well, see, that's different. I think we only have one that changes at 0 with an open and 2 with a closed. The only one that changes at 0 and at 2 is letter B. See, we've got 0 and we've got 2 with a gap in between them. So the answer for that one is B. Number 4. This one changes at -2. It changes between -2 and 2, and it changes again at 2. We have 3 sections. We only have 3 sections for letter D. Also, this is the only one that has an x squared, which is the U shape. Number 5. I keep losing my green highlighter, y'all. Number 5. Number 5 changes out +1 and +1. It's got a closed circle and an open circle. 1, all we have left is C and F. Well, F changes at 1, so it has to be F. Okay. Number 6. Number 6 changes at 0 and 0. The only one left is C, but let's make sure. Does this really change at 0? Yes, it goes up and then it goes up. So the answer is C. All right, we are going to talk about how to actually write a piecewise function, this, once we are given a graph. So we're going to talk about that. There are pieces we'll have to know, such as what the domain is, if it's open circle or closed circles, and then what the equations of the lines are. Okay, so we're going to come back and do that in just a second. All right, so now that we have matched them, we are going to write them from our graphs. So we are going to have to identify, first of all, the domain, which is this part right here. So let's do that first. So get your highlighters again. We are going to highlight this part. So the domain is the x values, of course. This graph starts in this direction and it stops at 2. Now, that is all of the values that are less than 2. So what I'm going to do is I'm going to make an f of x equals, make a curly bracket, and I'm going to put the domain over here. So the domain, so an x, these are the numbers smaller than 2, so less than 2. It is no line underneath because that is an open circle. That is this part. X is less than 2. Okay, now let's talk about the rest of the domain. From here, and it keeps going forever, that is when x is greater than 2. Now it is greater than or equal to 2 because it is a closed circle. Now we need to talk about the actual function. This is a horizontal line. Whenever you see a horizontal line, that means it's going to be just a number. This number is 1, 2, 3, 4. So it is 4. There's my function. All right, and here, first of all, we are going to need the slope. We will need the y-intercept. And then we will have y equals mx plus b. The slope looks like from here to here, it's going down 1 over 1. So the slope is -1. The y-intercept, I'm going to take a straight edge and figure it out. I'm going to line this up perfectly as I can and see where it touches. And it looks like it's going to touch right here, which that is 1, 2, 3, 4. So the y-intercept is 4. That means my equation is y equals, but we don't put y equals, -1x plus 4. I don't have to put the 1. I could just put -x plus 4, but either is correct. Okay, -x plus 4. There is my piecewise function. Let's try 10. We have 3 pieces in this piecewise function because I have here, I have here, and I have here. I'm looking for every single time that domain changes, every time the graph is changing. So f of x equals, going to have 3 of them, So I have right here is -1 when x is less than -1. So this green portion. I have when x is between -1 and 3. To write that, I write -1 less than x less than 3. Close circle, so or equal to. Okay. Then I have when x is greater than 4. Not 4, very sorry, 3. The orange piece of the domain and the pink piece of the domain. Now we need to write the functions. This function, this slope, up 1 over 2 is 1/2. The y-intercept is right here. That is at 1 3/2, -3/2, or -1.5, either one. So 1/2 x minus 3/2. The orange piece. The slope is 1. The y-intercept, thankfully we can see it, is 1. So x plus 1. The pink portion, when x is greater than 3, is a horizontal line. That means it's a number at 1, 2, 3, 4. There is my piecewise functions. Now we're going to do the opposite and graph them. So we're going to graph them. Very important piece to know when we're graphing them. Again, this is the most important piece probably out of all of them, is our domain. It's going to change at 0. Okay, the first one has a slope of -1. It has a y-intercept of 0 since it doesn't tell us one. So I'm going to put a point on 0. I'm using a pen or pencil that I can erase because I'm probably going to have to come back and erase some things. And then I'm going to go down 1 over 1. And I'm going to connect these. Alright, now let's talk about what I need and what I don't need. This says this only applies when x is less than 0. That is here. That means I only need to keep this part. So I don't need this part. Put an arrow. This also says it's less than. So I need an open circle. I have completed the green portion. Let's talk about this portion. This has a slope of 1 over 1. The y-intercept is 1. That means I start at +1 and go up 1 over 1. And I connect. We'll talk about what we need. Okay. I'm specifically talking about the values that are greater than or equal to 0. That means I do need a solid line, but I only need the right side. So I'm going to put an arrow here. I'm going to erase this half. I have graphed my piecewise function. I want you to do the same on the one that says your turn. Okay, the important part to look at is the domain. We'll be talking about the values less than 2. And then I will be talking about the values greater than or equal to 2. The slope for this one is 1 over 1. The y-intercept is 0. Start at 0 and go up 1 over 1. And connect. Remember, you're going to want to draw it kind of light because we're probably going to have to erase. We only want the values that are less than 2. This is not less than 2. Put an arrow. Now, since this is not or equal to, we should have an open circle right here. There's the first portion. Let's graph the second one. In this one, the slope is 2 over 1. The y-intercept is -3. So put a point on -3 and go up 2 over 1, up 2 over 1, up 2 over 1, and connect. Then we'll talk about what pieces we need and what we don't. Okay. We only need the values that are greater than or equal to 2, which means only, we don't need these. We need a closed circle here and it to go on forever. There is my piecewise function. Today, for homework, you're going to try some of these. I will see you tomorrow. Oh, wait, let's glue it in first. Whoops. Okay, glue this in on page 44. I almost forgot. Remember the title? We already have that. It goes glued in on page 44. Then you can, head on out. Okay, now, for real, we're good now.